Analog signals. An analog signal is any continuous signal which changes to represent some other time-varying quantity. An example is an analog spring scale that is used to weigh objects. When you use this scale, you could weigh something as 2 pounds 1 ounce, 2 pounds 1.6 ounce. It has a continuous variable. For example, this would be an analog signal. Here's an analog spring scale. It signals, right? That's the whole point of this chapter. The weight of the object placed on it by pointing to a number representing the weight. So this one says it weighs 3 3/8 ounce, even though there's really nothing up here. This should be part of the scale, but let's say it's weighing that. The whole point is it can be any value between 0 going all the way around up to 16 ounces. You're not just limited to it has to be 1 ounce or 2 ounce or 3 ounce or 4 ounce. No, it can vary continuously between all those numbers. A sound wave carries a signal, which can be speech or music, for example, as varying air density from a speaker to the listener. So what is that? Well, here's our speaker that's either putting out music or somebody talking. Here's our listener. Well, it's his ear anyway. And what these dots show here, this is where all the air molecules are very close together. Then they spread out when the person takes a breath. Then he talks again, projects out the sound waves, which compress the air molecules. The signal, here's our signal, right? Here's the molecules down here. The signal represents them. It is continuous as it can take any value. The signal has a maximum value when the air density is the greatest. So here's our maximum signal here, and the air density is very large there. Once we get this analog signal that represents the air densities, and let me just draw it again, it looks something like this. Actually, it'll be way more complex than that because this is just one frequency. People talk in many different frequencies. We convert it in two ways. We have AM and FM radios. We'll talk about them shortly. But we start with the analog sound signal. Okay, that's the actual signal coming out of the microphone. We then convert it to analog electrical signals, and that's done with this equipment here. Don't worry, there won't be a quiz on it. It's then converted into analog electromagnetic waves, and that leaves the antenna here and goes off to another antenna. So let me just erase that, because I wanted to show you something else here. Right here, this is the transmit part. See this red line? Where we're converting the sound of music, an instrument, somebody talking into the microphone, converting it to electrical signals, and then into analog waves that can be transmitted through the air. Then at the other end, and let's highlight that here, we've got this red parentheses here. We receive electromagnetic waves with the antenna. It is then converted into electrical signals. Those electrical signals then are converted into analog sound signals, and out of the loudspeaker you can hear what this person was saying or what music was playing. Analog signals can be stored or recorded and retrieved or played. The following technologies over history have been used to record mechanical data, such as pressure, temperature, vibrations, or sound or video. Okay, this could be air pressure, air temperature, and you could have vibrations of the earth if you're looking for earthquakes. There are chart recorders which draw a graph on paper, vinyl records which have grooves in them that a needle will track along and oscillate on, which means move back and forth. That will follow the original sound signals. And then magnetic recording tapes, cassettes, might be a few of them still out there. They have an image of the electrical signals that resulted from conversion of the original signals. Analog applications. You have rotary or round watches and clocks. Some people still wear watches with a little needle in the middle of it going around. Clocks show that, analog clocks. Rotary or spring scales, we showed that earlier in this chapter. Car speedometers, thermometers and thermostats, pressure gauges, like when you fill a bike tire, seismographs, and that's one of those chart things. You can plot the movements on paper. Phonographs, those are the things that play those vinyl records. AM and FM radio, and specialized scientific instruments. What are the benefits of analog technology? Well, they were simple to make, such as a spring scale. You just need a spring and some kind of pointing device, and you don't really need complicated electrical circuits. Actually, you don't use any in a spring scale. Easy to broadcast, AM and FM radio or TV, well understood technology. Can be easy to figure out. If you look at a vinyl record, even with magnifying glass would help too, you can see the grooves in there that have wave patterns, and that's what the needle is bouncing up and down side to side on, which will then be transformed into electrical signals, then sound signals. But if you look at a plastic USB flash drive, which is not analog, you have no clue what that thing is doing. There are drawbacks of analog technology. First of all, they often suffer from noise interference when you're transmitting, which ruins the signal, especially over long distances going through the air, or even going through copper wires. So you might have a signal here which perfectly represents somebody talking or music, and by the time it gets to the other end, interference could mess it up like this. And you hear that as static. And that's why you get static on an AM radio when you're too far away from the transmitting tower, or frankly, even close to it, depending on the weather. You have to keep analog radio and TV transmission frequencies apart from each other. They have to be separated into things we call bands, so they won't overlap. So here's our frequency down here, right? 10 to the 6th, 10 to the 8th hertz. And AM radio can only use these frequencies. FM can only use these. TV can only use these for channels 7 through 13. That's in the olden days when you only had 13 channels. And here's 2 through 6 over here. So you didn't have a whole lot of room. There's not enough bandwidth for all of us to communicate with each other on AM and FM and TV. It's difficult, if not impossible, to keep analog transmissions and recordings private unless you put some heavy-duty security gear on it. That's why sometimes you can pick up other conversations when using walkie-talkie radios, because the transmissions are just going out in the air. Anybody with the right receiver can hear what's going on. Space. Let's talk about music. Analog recording media, vinyl records, take up a lot of space. 1 hour of music requires a vinyl disc that is 30 centimeters in diameter and a storage sleeve. Together, these are nearly 5 millimeters thick and a mass of 150 grams, which is 1/3 of a pound. We have 6 vinyl records here. They weigh 2 pounds, but they only hold 4 hours of music. Six records there, and that's on both sides because you can flip them over. Analog recording media are easily damaged and can take a long time to copy, reproduce. Here's a close-up of a vinyl record, and hopefully you were able to find a magnifying glass and a vinyl record to see this for yourself. Those grooves should be perfectly clean, and there shouldn't be any lines like this one. Those are going across the grooves. That could be dust. It could be where you grabbed it wrong with your fingernail and cut it. It could be the needle moving out of a groove and scratching it. So it's very hard to keep safe these things. And making them, the first one they actually cut the grooves with a very sharp needle, cutting them all, and then they press them onto other pieces of plastic. It takes a while. Analog technology is not very portable. Here's a record player. It's kind of hard to carry that in your car, and especially if the record's spinning around, it'll bump too much when the car hits bumps. So playback of vinyl records requires bulky equipment. Here's a cassette, which is a lot smaller, but still, you need a little cassette player here that you hook to your belt while you're walking around. Here's some pretty archaic earphones, headphones. And the cassette tapes, they can be played on the go, but one tape would hold 2 hours of music at most. Despite the limitations of analog technology, they enable us to get through the 20th century and hear sports, music, watch TV and movies, communicate, and make scientific measurements. So that was good. The problems, along with the need to speed up mathematical calculations during World War II, led to the development of the digital concept and the technologies that followed.